This lecture is part of an online course of multivariable calculus, and I'm going to talk about how to sketch polar curves in two ways. So let me start. Basically, polar curves are like this. R equals to f of theta, where theta is between some alpha and beta. How to sketch them? We can plot points. Basically, we're going to give some numbers to r and theta, and then we're going to find the points and we're going to connect the points. So this is just plotting the points, or we can convert this equation, the given equation, to Cartesian coordinates. And then we can just sketch the Cartesian equation. So let me explain in one example. R equals to 2 sine theta, where theta is between 0 and 2 pi. Okay, so I'm gonna give some numbers to r and theta. So r and theta. So r can, let me give numbers to theta, and then we're going to find r. So when theta is equal to 0, r would be 2 sine 0. Sine 0 is 0, so I get 0. When theta is equal to pi over 4, I get 2 sine of pi over 4. Sine of pi over 4 is 1 over root 2, so r would be 2 over root 2, which would be root 2. Then pi over 2. Sine of pi over 2 is 0. It's 1. So r is equal to 2 times 1, which is 2. Then 3 pi over 4. 3 pi over 4 would be sine of that. Sine of 3 pi over 4 would be 1 over root 2. And again, r would be root 2. And then let me go to pi. Actually, let me change the question into just pi. Okay. And then I get 0. Now, let me connect the points and see the equation in the xy plane. Okay. So 0, 0 would be here. Let me use another color. 0, 0 would be here. Then I get root 2 and pi over 4. So I'm gonna have part of the circle of radius root 2, and then I'm gonna say that this angle in here is pi over 4. So assume that, for example, somewhere in here, this is the point root 2 and pi over 4. Okay, and then 2 and pi over 2. So from the positive x-axis, I'm gonna go to pi over 2, and then I'm gonna have like this as 2. So I get the point 2 and pi over 2. Then I go to 3 pi over 4, and then just assume that somewhere in here would be root 2 and 3 pi over 2. 3 pi over 4, and then 0 and pi. When r is 0, always we have on the origin. So if I want to basically connect the points, I get like this. Just assume that it's a nice circle. Let me just move it a little bit so that I connect the points. Okay, there we go. I'm gonna move this point just a little bit so that I have a nice circle. You see 0, 0, and then 0 and pi, and then this is the point 2 and pi over 2. So you see I got a circle of radius 1 at the center 0 and 1. Now let me convert it into Cartesian and see how we can solve this problem. So r equals to 2 sine theta. Okay, I'm gonna multiply by r both sides of the equation. So I get r squared equals to 2r sine theta. You know that r squared would be x squared plus y squared in Cartesian, and r sine theta would be equal to y. So what do I have? I have x squared plus y squared equals to 2y. I'm gonna bring 2y on the other side. I'm gonna add 1, subtract 1 equals to 0. It's just because I want to make it a perfect square. And you see what I get. I get x squared plus y minus 1 squared equals to 1. This is the same thing. It's a circle of radius 1 with the center 0 and 1. Okay, that's the same thing that we got for that. Okay, so let me give you one more example. When we have r equals to 2 sine theta, where theta is between pi and 2 pi. Okay, I'm gonna use two ways. The first one is by plotting points. Plot points. Let me have just the line in here. I'm gonna have another line in here. This is theta, this is r. So let me give some numbers to theta. Theta equals to pi. I get sine of pi, which is 0. When theta is 5 pi over 4, what do I have? I get 2 sine of pi over 4 is negative root 2 over 2. So when I simplify that, I get negative root 2. Then I get 3 pi over 2 sine of that is negative 1. I get 7 pi over 4. 7 pi over 4, the sine of that is a negative 1 over root 2. If I simplify that, I get negative root 2. And then when I go to 2 pi, I get 0. Okay, now I'm going to plot the points and see what I get. X-axis, y-axis. Okay, so the point that I have in here, let's see. The point that I have in here would be the point 0 and pi, which is the origin, right? When r is equal to 0, I'm at the origin. Then what I have in here, I have the point negative root 2 and 5 pi over 4. You know that when r is equal to negative, it would be the same point with r positive, but 5 pi over 4 plus pi. Okay, which is what? Which is 2 pi plus pi over 4. Basically, we just flip the points on the opposite side of the origin. So we are in here. This is 2 pi plus pi over 4. We are somewhere in here. So this is the point negative root 2 and 5 pi over 4. When we are at negative 2 and 3 pi over 2, we have the same idea. It would be the same as 2 with the positive r and 3 pi over 2 plus pi, which is pi over 2. It's the same thing. So pi over 2 and pi. So we are here at 2 and pi over 2. And for this one, this is the same as root 2, and 7 pi over 4 plus pi, it would be 3 pi over 4, which is the same point as this. This is negative root 2 and 7 pi over 4. It's just because, as I explained, when r is negative, let me erase this one. We get the same point as when we flip it. Now let me connect them. Okay, when I connect them, I'm gonna just move this point just a little bit so that I have a nice circle in here. Okay, so I get the circle of radius 1 exactly as before. Okay, but you can compare the equations. Okay, if I want to do it in the Cartesian, in Cartesian, we have the same equation as this one, so we get the same curve. You see, the theta here is from pi to 2 pi. The theta here is from 0 to pi, so we get the same circle. So theta plays some roles in here.